Hello and welcome to Meep's Math Matters number 10, and today I'm going to be talking about parity. Now parity, this is not to be confused with parody, the comical technique. Parity is generally referring to even or odd. So arguments where this come up often happen when you have sums and when you have products, when you're multiplying things, because if you have an even number plus an even, you get even. Even plus an odd, you get an odd. An odd plus odd, you get an even. You have something similar going on with multiplication. Even times even is even times odd is even, and odd times odd is odd. Not going to prove these, but we'll use some of this, and we'll look at a couple of problems that use these parity arguments. Consider the situation where we have two boys, John and Pete, and 3 pieces of paper. At any given time, one of the boys picks up a piece of paper. If it's John, he'll pick up a piece of paper and tear it into 3 smaller pieces. If it's Pete, and he picks up a piece of paper, he'll take that piece of paper and tear it into 5 smaller pieces. Okay, so John and Pete will be taking turns, not necessarily one after another. John could pick up a piece of paper, tear it into 3 pieces, then pick up another piece of paper, tear it into 3 pieces. The question is, they start with 3 pieces of paper. Is there any way to end up with 100? And the answer is no. And in most of these parity arguments, the question is something possible to do? And you're going to use a parity argument to show that it's impossible. And the reason is this. Every time John takes one piece of paper, whatever number you started with, n say, and you're taking one of them and turning it into 3, you're going to end up with n plus 2. Similarly, with Pete, every time he takes one of the pieces of paper and tears it into 5, you first had n pieces of paper and now you have n plus 4. So if you see this parity argument, you start with an odd number of pieces of paper, and every time John or Pete rips up paper, you're going to have the same parity because you are adding an even number. When you add an even number to an even number, you get even. When you add an even to an odd, you get an odd. Adding by an even number keeps the parity, okay, preserves parity of the number. So you can't possibly get 100. You can get 99, you can get any odd number, but you will not be able to get 100. Consider another situation. We have a checkerboard here, hand-drawn, of course, and we want to cover it with dominoes. Now, each domino covers 2 of the squares on the board. Now, with a full checkerboard, you can do this. Now, the question is, let us take out, so what I'm marking in red, I'm going to take out these 2 corner squares, and I want to cover all the remaining squares with dominoes. And the question is, can it be done? And again, with parity arguments, you're usually proving you can't do something, not that something is possible. And the way this argument works is, notice that every domino has to cover a black square and a white square. So it's going to cover the same number of black squares and white squares. When you start out with an 8 by 8 checkerboard, you have an equal number of black squares and white squares. When I remove the corners here, I'm removing 2 white squares. So now there will be 2 more black squares than white squares. Okay? So when you pair up the black and the white, there's going to be 2 black squares left over. You can't do this. And this also shows you where the origin of the word parity comes from. It's from pairing. Okay? Now here you're like, oh, what's even and odd? What is even and odd here? We're looking at pairs. We have black, white. It's like even, odd. And sometimes it's also negative, positive. That's the next problem I'm going to look at. For this problem, you're told that there's a product of 30 integers equaling 1. So x sub 1 times x sub 2 times x sub 3, etc. equals 1. Can their sum equal 0? Now, first off, have to note, okay, integers are just the whole numbers, positive or negative. So like -1, -2, 0, 10, etc. Those are integers. And if I want the product of integers to equal 1, I can only have 1s and -1s. Okay, if I have a 2 in there, then I'd need a half or something like a half to get it back to 1, and it wouldn't work. So I have 1s and -1s. And, you know, n and 30 minus n. I'm not going to explain that right now. If I wanted the sum to equal 0, the only way to do this, again, here's parity or pairing. I have to have the same number of -1s and positive 1s. Okay? They have to be the exact same number for them to cancel each other out. And since there's 30 total, that would mean there have to be 15 -1s and 15 1s. Okay, good enough. Now, that's their sum equals 0. What would their product be? If I have 1 to the 15th power, 15 1s times 15 -1s. Well, here comes parity again. So parity, first of all, told us that I have to have the 1s and -1s paired off for the sum equaling 0. And another parity is negative and positive. So negative times negative is positive. Negative times positive is negative, and positive times positive is positive. Okay, and what happens with this, okay, so 1 to the 15th power is positive, fine. -1 to the 15th power, though, is -1 to the 14th power, so -1 times itself 14 times, times -1. A negative number to a positive power, you will have 7 pairs of -1s. This is 1, and that's 1 times -1, that equals -1. So I can't do this. Okay, so I'm using a parity argument twice. Once to say that there's the same number of -1s and 1s for the sum to be 0, and then for showing the product has to be negative. Okay, now parity arguments show up in a lot of contrived situations like these. I mean, there's nothing particularly natural about this, but the concept is you have to pair things. It's problems, and a lot of it's sums and products, where things being even or odd, or negative or positive, or pairing things up are important. Okay, so this is like pigeonhole principle. It's one of these small ideas that pops up and is used in a lot of weird places that you wouldn't expect. So keep your eyes open for the parity arguments, and remember to spread the math love. And I can be contacted at marypat.campbell@gmail.com.